cycle through these just to make sure. All right. So the dialogue.
All right.
And the screencast. Hey there, Morgan. Decentology says to me. Who's that? Who's Decentology? So, this is the inaugural, and Jacob, bear with me if it's just the two of us. I'll still talk as if there's an audience.
Yeah.
All right, so this is the inaugural Flow Developer Hours presented by Decentology. I'm your host for today, Morgan. With me is the awesome Jacob from Decentology. Please introduce yourself.
Hello. Yes, I am Jacob here with Morgan. Me and Morgan did a bunch of these together during the Fast Flower Boot Camp that ended only a couple weeks ago. So we're back at it again. And as of now, it just looks like it's us two, but we'll still have some conversations here, and they'll be recorded on YouTube, I guess. So
for posterity, this will be accessible maybe in an edited format. We'll cut out the bits that are unhelpful, and yeah, we'll do these 24 times during this hackathon. So, I mean, it'll get boring by the end of it, I'm sure.
yeah, at some point we'll run out of stuff to talk about, but for now we'll we'll just talk about whatever.
Yeah. So, and the whatever part is flow, since oh dear, Jacob, you shrunk yourself.
Am I shrunken?
Yes, you are shrunken.
Oh yeah, I am shrunken.
Dear Lord. All right. maybe this is a good time to transition into our screencast, which is where we will do most of our damage and where any developer would likely start their journey. Dab Starter removes a lot of fiddly bits when it comes to setting up your environment. Because if you go to, and this is something that we'll just go through together. So let's say you're interested in developing a decentralized app with Flow, which is a blockchain, and it uses Cadence to write smart contracts. What do? You go on flow.org, and there's a bunch of links. There's documentation. Obviously, documentation is a good reference, but a starting point, we can do better. We just want to, see something appear on screen. One sort of substitute for the real thing that they have is Flow Playground. It is a little bit finicky, and it works. Yes, definitely finicky, and something that we'll get to experience. But in my opinion, something that we've built is a better place to start if you just want to see stuff appear on your screen. And that thing is called Dab Starter. So if you want to find it, just go to decentology.com. We'll try and put these links in the description. And click on Start Building. This will take you to a link, dabstarter.decentology.com, and you'll get to select a smart contract that, or components for your smart contract that you're building. We'll select Flow and Cadence for the blockchain and language. Let's do React for the framework, and let's pick one foundation. We'll get into more what foundations are when Jacob joins us in the presentation for his presentation next week. And we'll just give it a name. Our first dApp. All right. And then we just click that button. Obviously, if you're not logged in, you'll need to create an account with Decentology, but that's a simple process and should take less than a minute with an email account. Alrighty, so what that did, that created a repository that we can go and visit with everything that you need to start working on your Flow decentralized app. Now, it has a README for how to install things, but there's a really cool hack that allows you to get started even faster than reading any of this. So here's the steps so far. We went to decentology.com, we started building, we selected some customization options, and then we have a GitHub repository. Let's clone that repository. And I do hope the font size is good, but I'll just bump it up maybe a little bit. Cool, so it got cloned, and let's CD into this. I'm using the iTurn 2 for the Mac. And we have this command that we can run. It's npm run develop. So all you need to be able to execute this command is Node installed on your computer. That will have npm with it, and if we just run this, it will start creating a containerized environment. So that's a lot of fancy stuff to say that we abstract all the complexities and put everything into one machine that's running in the cloud, and you have access to it for free. That's a pretty good bargain, right, Jacob? And like what we're enumerating right now, this might pop up if you're on a Mac. Just click on allow. And what we're enumerating here is a lot of stuff that you only realize that you need. By the way, I have a container running, so that's why it's stuck a little bit, but it completed the container creation process in 25 seconds. And once you're done, you'll be in the container through SSH, and you'll have the command line interface ready to go. So the thing is, everything that we just mentioned, it would take time for you to understand that you need those things, right? And to save you time, we went through all the hassle. And so what you have when you complete the node, or rather npm run develop command, you have a folder that looks a little bit like this if you're in the command line. And you can open that up in VS Code. And you'll have your packages, which is the folder that contains your client code, your server code, and your decentralized app code. Jacob, you want to walk us through a little bit on what each folder is for? Yeah, Jacob, real quick. What we want for now is to get real quick to some kind of executing of flow source code, and the core of DevStarter is assembling these contracts with client and server code, and like Jacob said, we put decentralized app contract code in daplib, and server and client. Jacob, what do those do? Here we go. And again, like Jacob mentioned, we'll go into more depth. We'll really hit some of the notes on how to use this thing. But we want you to get your hands dirty and start exploring flow and cadence. And Rodrigo, you can't hear Jacob? This is interesting. We did test this out, and it should be pretty legible. Let me see if I can fix this. We didn't try talking over a screencast, both of us, so.
YouTube and see if I can hear myself.
So that way you should be on the stream. Rodrigo, does that help? Jacob, please say something.
Oh yeah. Okay. So can you hear me now, Rodrigo? Now that I'm actually on the screen.
Just a
hopefully
quick
you can.
Confirmation, seconds away. Awesome. This is perfect. So there was a lot of stuff that Jacob mentioned that we'll get over more in depth when we do this next week with Jacob at the wheel. But the essence is when you open up your Git repository that is created after you run dapstarter.decentology.com, you'll see in your packages 3 folders: client, daplib, and server. And daplib is where your decentralized contract stuff resides. Server is when you will author authenticated transactions, things that can't run on the client. And then the client code is where you'll put stuff that a user can click and interact with. And it will also contain a UI harness. But the core of what we're doing is we're trying to understand how Flow works, how you can work with it. And since a lot of folks that are attending this hackathon are really exploring blockchain for the first time, we want to start with how you would start, just looking at and running some code. So I went to this folder, app packages daplib temporary, after I ran npm run develop. And after you log into the container using npm run develop, you'll have to run 2 commands. First one is yarn. That'll take a bit of time. And the second one is, after it's completed, yarn start. So that will start our dapstarter instance. That will start a whole bunch of other stuff, including the Flow emulator. And with the emulator on board, you can start running Cadence code. Now I created a temporary folder here to include the bits that we'll be working on today. And this, ladies and gentlemen, is 3 lines of Cadence code. Main delineates that this is the entry point to the source file, and then log just logs anything that's inside to the terminal. All right. So with that, let's try and execute this. So we have a Flow emulator running, and we can go ahead and run or execute this file using Flow, Cadence, and then the name of the file. So as we can see in this log right here, we have hi again, which is the log statement that's presented there. Hi, Thomas. Thanks for joining the stream. So we're going to try and experiment with some of the features that Cadence provides. Now, Cadence is a blockchain language. That means that it doesn't have a whole bunch of stuff that you would find in, let's say, JavaScript or any kind of other a programming language like that for client or for server. But it does have sort of interesting baseline types and features. So let's start with some administrative stuff, I guess. When working in any kind of source, you want to document stuff. So we have single line comments like this, and we have multi-line comments like this. And it's just really good to keep your code legible, easy to understand, easy to collaborate with. And you can even nest these together, something else. So just, try and keep your contract code well commented. It will come into play when other people will try to interact with your contract. This is the blockchain, so anything that's on the blockchain, people can interact with even without your permission as the core developer. All right, so now let's explore some basic variables. Cadence has variables that you declare with the keyword var, and it has constants, things that won't change. Maybe I should make this a constant. So let is the keyword that creates a constant, and var is the keyword that creates a variable. So what I just did was I created a constant for name. My name is Morgan, and a variable for age 32. All right. So when things change within the execution of your contract, you should pick the appropriate type. Now, speaking of types, Cadence is a strictly typed language. That means that unlike JavaScript, you can't create a variable with one type and assign different things to it, like change the type. Cadence, everything is set in stone. But it has a nice quality of life feature, which is implicit types. So when I did this double quotes Morgan, it implicitly set this to the string type. And when I did my age right here, it implicitly set that to int. Right, Jacob?
Yep.
What other types would you say are useful for a Cadence developer?
Well, the two other big ones that I can think of are arrays and dictionaries.
Well, those are sort of more complicated types, but there's Boolean, right?
Yep, Boolean. Yep. Oh, yeah, and there's also unsigned integers and fixed integers, which I use a lot.
Yeah, there's a lot of options when you're dealing with numbers. Cadence numbers are implemented, the int type numbers are implemented as big nums. So what you get is an arbitrary precision number. Essentially, you can make it as big as you want, as big as the universe. Cadence can accommodate for that. And this is pretty helpful when you're thinking about the blockchain. But like Jacob said, you can have things like int 64, and that will be 64-bit wide integer that you can assign to it. Let's see. Jacob mentioned something that we provide in, I guess, Flow provides, but we integrate it with this development environment, and that is compiled time errors. So when you do something wrong with Cadence, it will let you know. So what's a syntax error that you often find yourself making, Jacob?
Well, there can get some pretty complicated ones, but one syntax error that you could run into a lot is, like Morgan was saying, types are very set in stone. So if you were to try and change age right now to be a string or something like that, you would see that it would probably give you an error about expecting an int and instead receiving a string, and it does that because of the fact that the types are so strict.
Yeah, like we can see on the screen right now, we can't reassign it to something that's inappropriate. We obviously can reassign it to, let's say, 33, and that's all fine. But when it comes to constants, no matter if the type is correct, it's still a constant, so we can't assign it to something else. Like I can't rename myself to Jacob. No matter how awesome that name is, it's already taken. Yeah, and you'll get to see those VS Code errors in line when you're making something ungodly as trying to change your name. So here's the thing. Variables, that's cool, but we want to start interacting with them, like using them in things. So here's a quick way to use our two variables that we have upstairs. So let's say we want to log in our string the name and the number. So strings have some functions, and I want to show you how to find those functions when you're just getting started. So I shifted back to docs on flow, and we're going to open up the cadence reference. It's in the top left. In fact, I can share this in the chat. So this is the link that you might want to go to. And for now, what we're interested in, the question that came up is, what can we do with strings, right? We want to combine them perhaps. So we go into values and types, and from the right here, we find strings and characters. So this takes us to the section that includes all the descriptions of what a string is and how to deal with it. Some fields like length, just defines the length of a string, and concat. All right, so concat is the method I was looking for. It says that it concatenates a string with other and produces a new string. All right, so what we get is something like this. All right, so with that newly acquired knowledge, we can go ahead and concat hi with name and see if that pops up in the terminal. It did, thank God. The documentation did not lie. So what we have is another example of how, let's say, strict cadence is. Some languages you can use the plus symbol, you can overload things that you can do with your basic types. Cadence, you can't. The only way to combine two strings is concat, and that is it. There's no string interpolation, and stuff like that. But we can go a step further and concatenate this with another string. So let's say it says hi Morgan, and let's add and then concatenate that with age. So we see an error. It says types mismatched. Concat expects a string, but it's getting an integer. So this is an example of that. Cadence does not implicitly convert any variable into the target variable. Like, you have to explicitly tell it, hey, I have an int, I want it to be something else. In this case, we want our int to be a string. What will we use, Jacob, if we wanted to convert an integer to a string?
ToString.
Tostrings. Now, Jacob is an experienced developer. He's a Cadence pro. He's been around the block. But if you don't know, if you don't know, you might as well go to the language reference and see what is available. And in the integer function section, you can see that there's a function toString, and it returns a string from our integer type. So we'll go ahead and use that toString, and the compiler's looking good. It's no longer complaining. Let's run that again, and we're not seeing anything appear on screen. All right, boom. I didn't save the file initially. So it says, hi Morgan, I'm 32. It's a bad example, but it goes to show that you can combine these different types. You can look up the available functions for these basic types on in the Cadence language reference. And it's a useful resource, and it's good when you know what you're looking for. All right, so Jacob mentioned arrays and dictionaries as some of the favorite types that he's using. Do you have an example to run through for what an array does?
Well, what we could do is just declare an array, and I guess declare its type to be an array of strings, and then maybe we could, just put a bunch of strings in there, like your name, last name, my name, stuff like that, and then we could just try and log that array to the console and see what comes up.
All right, that's a great suggestion. Let's do just that. So the log function is very helpful when we're dealing with just basic inception level code where we're experimenting. We want to see what values are we getting, and so it's just going to print out sort of a system render of the type. And arrays and cadence are declared using the square bracket, and the type, just like we did with strings and integers, colon int, colon string. We're doing the same thing with colon, square brackets, string, and then equals the array itself. However, this is not the only way to create this array of Morgan and Jacob. We can declare an empty array. And how can we add to this array, Jacob?
So what we could do is, like Morgan was saying, go to the documentation and then use the look for the .append function, which will add certain strings to that array.
Here we go. We're inside of the documentation and we're looking for fields and functions. So we have concat, we have contains, append. Boom. This is what Jacob said, append. So it takes in an element and returns nothing. All right, so let's see it in action. We'll go ahead and append, and let's append Jacob since he's the author. Save this and run it. Boom. So we appended items to this array, and we can expand the array to make it as big as we want it to. In fact, let's add another element just to prove it. Boom. We got Jacob and Morgan inside of this array. Now, arrays have a bunch of other functions that are pretty useful. When you think, adding, removing everything, removing the first item, the last item, stuff like that, you'll find using those quite a bit in your source code, in your smart contracts, because we're working with collections of NFTs. We're working with collections of users, all kinds of collections. Oftentimes, you can use an array type for that. But another type that you can use for your NFTs is dictionary, right, Jacob?
Yep, dictionary.
Let's go in the reference. And how would you describe a dictionary? Like, what's the difference between an array and a dictionary?
Well, when you think of arrays, it's really just, like any other programming language. And if you're not familiar with, programming, it's more just like, a list of elements, right? So, if we have an array of strings, it's just, maybe Jacob, Morgan, my last name, Tucker, a bunch of other stuff, right?
Jacob, I'll go with the dictionary of capitals, countries and capitals.
Yes, yeah. So with dictionaries, it's more like a mapping. It's like you have a key and that maps to a value. So, if I guess before we get into this example, if we were using like names, it would be like, the key would be name and then the value would be Jacob, right? So it's more of like a mapping. And this is really helpful for a lot of things, which, we'll maybe go into in a different time. But as you see here, Morgan is mapping capitals to he's mapping countries to capitals, right? So Japan, Tokyo, France, Paris, right? So it's the key is Japan and the value would be Tokyo.
Correct. And when you're assigning, when you're creating a dictionary, you're creating a quick to access map. As long as you know the key, it's really quick to find the value. With arrays, if you don't know the index where an element lives, you need to iterate over the array to find the exact element you're looking for, and that might take a long time. And the blockchain, it takes, everything takes a lot longer on the blockchain anyway. So you want to optimize your lookups, and if your lookups will be based on something that's well known in advance, perhaps stored off chain, like a account address where your client is, or a name or something, using a dictionary is a good choice. So with this example, I want to go through a capitals dictionary where countries are mapping to their capitals, and just show you how to work with it. So we initialized capitals with 2 countries and 2 capital cities, but we can go ahead and add a third one. So we're going to use the square bracket notation, and we'll define the capital for England, which is, I'm sure everyone knows this, London. And let's see it print in the emulator. All right. For further functions and fields, we can go to the flow cadence language reference, and we'll see that it contains, we can look up the length, how many elements are in the dictionary. We can insert items for a given key with a given value, remove items, and so forth. So again, the flow language reference is really good when you know what you're looking for to expand your understanding. So that covers types, and types where we combine other types. Although I'm careful to not name these composite types, because that's a whole nother thing in Cadence.
Yeah, whole separate thing.
Whole separate thing. So now that we have some types, we can take those types and start interacting with them with the help of functions. So how would you use a function in Cadence, Jacob? Like some example use cases.
On arrays and dictionaries specifically, or just in general?
Just general, like, with math.
Yeah, so usually with functions, you would just do something like pub fun, and then the name of the function, and then you would open up your your parentheses, and you would put all your parameters in there. There's a lot of nuances that go into that, and then you open up your curly brackets. So should we go into like parameters and stuff like that?
Yeah, let's, let's go with a specific function, and let's implement an adder, like a function that adds 2 numbers and returns the sum.
Yeah, that's a great example. So what you're going to want to do is, if you're taking in parameters, you're going to first specify the name of the parameter. So the first one we can name like x, for example. And let's just say that we're taking in an integer. So you would do x and then colon and then int. So you have to specify the type. And then if you want to specify a second parameter, you would do comma space. And then if we wanted to also do like something like y, you would do y and then colon int. So it's very important in Cadence that your parameters are, you specify the type, or else it will give you an error. And then what we're going to do is, we're eventually going to return an integer, right? Because we're going to add x and y together and return an int. So in order to do that, the return value, you do colon space int after the parentheses. And that specifies the type of the return value. All right, and then inside of the function, we're just going to return. So the syntax for that is just to return x plus y. Now, the one other thing I want to mention is that, actually, I guess we can go over that when we actually call this function.
Yeah, let's go ahead and call it, and we'll do that inside of our main function, which is the entry point for this. And we can go and call it directly inside of log, and let's pick 2 numbers. Let's say 1 and 3. Okay.
Perfect.
And
yeah,
let's run it. We got 4. Does that compute? Is that 1 plus 3?
All right. Yeah. Yeah. Seems about right.
Checks out.
Now, the one thing I do want to mention is that you see how when we call the add function, we had to specify exactly that x is 1 and y is 3. And the reason for this is because of the fact that when we declare the add function, we put x:\int. But there's a syntax we can use. It's a little underscore. So if you put the underscore before your parameter value and then a space, what that means is that it's actually optional to put that label there. So what I mean by this is, like, for example, if we were calling, the add without label function, what you could do is just call add and then pass in 1 and 3. You wouldn't even have to say x and y. So that's a little sort of cool thing you can do.
Let's go ahead and run it.
If you don't want to, type out x and y every time. But most of the time, you will see people using those labels.
And that's because it is very useful. When you're reading through a contract, when you're reading through source code, you want to understand what this function does. Not only where it's declared, but where it's used. And it's all fine and dandy when you're declaring a function and it's clear what it does within the body. But at the call site, it's really nice to know what those values that you're feeding in are. And this goes back to why Cadence is constructed and created like it is to enforce and encourage legibility and developer quality of life improvements, such as being able to read through contract code and understand what each thing does everywhere. So what we have here is 2 examples, one with labels and one without. If it's something that's extremely clear what it is, then the suggestion is you can include the label within the functioning. So if it's just one argument, but if it's something more complicated, always use labels. All right, so we have a very simple function, and we have a return value. So let's think of, so now that we have functions, we have values, we have types, we can start looking at things like composite types. And I was very careful not to name and call arrays and dictionaries composite types, but we can now go into composite types. There's 2 composite types that you'll find in Cadence. One that if you've done any kind of programming in your life, you should be pretty familiar with, which is structures or objects. Depending on the language that you're familiar with, a structure equivalent in JavaScript would be just an object type or a map type. And the other composite type is a resource, which is a linear type that's unique to Flow. It's got certain properties that enable an ownership experience that's pretty unique. But we'll get into resources another day, just so that we have some headspace.
Yeah, and really quick, Morgan, I just also want to say that I have to run, and I will have to run a little bit early for some of these office hours. But you're left in great hands, and Morgan, good luck with the rest of the office hours.
Good luck to you, Jacob. Thanks for joining, and bye now.
Yep, of course, bye.
Alrighty. So now that we're here together alone, we'll go ahead and continue with structures. So structures are value types, and value types are copied everywhere when you're passing them along, just like when you're passing along a name or your age into the log function. You're copying that and you're sending it to the call site. And this is something that we'll get to explore in later sessions. But let's just create something of a first for us, which is a struct. Now we'll go ahead and start with pub struct, and we'll create a rectangle structure. You open up the rectangle structure body, and it's a clean slate. You can do whatever you want. And let's just think about what does it mean to be a rectangle, right? Well, you're probably going to have a width, some kind of width. Let's name it, let's have it be of type int, and we'll have a height. All right, so now we have these two properties or fields, but it's complaining about something. So we can just hover over it, and it says missing initializer for field width. Okay, so unlike arrays and dictionaries and other types, composite types require an initializer for them to be valid. And you declare an initializer just like any function with the keyword init. And either you make sure you initialize your values with something that you come up with. You know, we can start with 0, 0, and that removes the warning, and this becomes a valid structure. However, you probably want your rectangle to have a variable width and a height. So you take in two parameters, and they both have to conform to the type that your property is in, and then you pass those along and you initialize your values. Now, self is a reference to the instance of the composite type. So if you're familiar with object-oriented programming, this is like a class, and an instance would be an instance of a class. So without further ado, I think we can just go ahead and initialize a rectangle. We have some space down here. So let's do a rectangle 1 or A, and we're going to call the initializer with, let's say width is 5 and height is 10. This is like going to be a portrait rectangle that we'll have. We can go ahead and delete these and just log. So again, log is very generous. It'll accept anything we'll throw at it, and once we run this, we can see in our terminal that this rectangle looks a little bit different from our previous examples, which were simple types. This is a structure with a specific width and a specific height. All right. Now, structures can have more than just fields which contain data. They can also have functions. So let's create one. Let's call it get area, and it will return an integer with a width and a height. We can calculate the area of a rectangle. Does anyone remember the formula in the chat? Just to check in who's listening. I'm waiting for a formula for a rectangular area when we know the width and the height. I'm going to give you 5 seconds. Whoever answers this first will get a shout out. Maybe the question is a little too difficult for y'all. No worries. We'll go ahead and fill this out right now. So we'll do self.width times self.height, because that's how you calculate the area of a rectangle. So now let's log this and see if anything changes in the log itself. Nothing really changed, and log just displays the fields that are on this composite type. But we want the area. So how do we get it? We get the area by calling the function inside of our log, and we get 50. 5 by 10, 50 seems about right. So this is how we add functions. Now, functions within a rectangular are cool because they interface with the instance. So we don't need to pass the width and the height to the function, and it has access or a pointer to the instance of a rectangle within it. And yeah, so that, any kind of object-oriented programming language, if you're familiar with that, you should be pretty familiar with how to deal with rectangles or other structures in Cadence. We did mention resources, so I'll briefly touch on what a resource is by declaring an instance of one. But like I said, we'll dive much deeper into that in later sessions. So there's another keyword. It's resource. And this will declare a resource composite type. So we had a name for our structure, called it rectangle. Let's create a resource called wallet. And the reason I'm naming this wallet is to sort of impress upon you that resources oftentimes are created to deal with property-like objects. Things that can only exist in one place, can be owned by one person, one function, one whatever, and they're moved through the system. They can be created, then they need to be placed somewhere, but by the end, they have to be stored somewhere, or they need to be destroyed. We'll get into that later, but just so that you know that this is a composite type for things that have value, and you want to assign those kinds of properties to them. All right, so what does a wallet contain? Probably some amount of dollars. So we'll go ahead and declare a field for our wallet, and let's just use unsigned integer for once instead of an int. And just like a structure, in fact, exactly like a structure, the body of a resource includes fields, includes an initializer, and includes functions. So those should be pretty familiar. And let's take a number of dollars and initialize our field with what comes through the initializer. All right. So we have a resource. Now let's see if we can run this. Cool. So let's initialize an instance of a wallet. Now the basic instinct would be, hey, I can just do wallet equals wallet. But see, the compiler's immediately complaining about that. And first, okay, incorrect number of arguments. So let's start with $10. There's still a complaint, and it says cannot create a resource expected create. So with a structure, you don't need like a new or any kind of other keyword to initialize it, but with resources you do. All right, no problem. We can use the create keyword. There's still a complaint, and we can hover over it, and we'll see that incorrect transfer operation expected an arrow. This just is an example that when dealing with resources, unlike structures or any other type, we want to be explicit, and the language itself will go to great lengths to show you that. All right, this is a resource. This is a movement operation. This is not an assignment. You're not copying anything. So when we go ahead and create a wallet, we move it into this wallet constant. All right, so we got rid of that warning, but there's one more warning left, and this is loss of resource. Like I mentioned, resources must be dealt with. They can't be lost. For example, this rectangle A, as soon as this scope is out, the main function is done executing, it will be garbage collected, removed from memory, and gone forever, never to be spoken of again. With a resource, you cannot do that. A Cadence will not allow you to run this, and in fact, if we saved it and we tried running it in our terminal, it's going to complain and won't allow us to run it. So just like we use the keyword create, we can use the keyword destroy to destroy our wallet. And at this point, we should no longer get any complaints. We get 50. And let's just make sure that we have access to the amount of dollars that it's in our wallet. And that should be 10. All right. So this is the gist of what using a resource is. Resources is a key concept in Cadence, and it's used for things like NFTs. All right. And this hackathon, Mercury, is all about NFTs, and you'll be dealing with resources every day. You're dealing with your contracts. The key thing is that an NFT has some value. It can only exist once somewhere. It has to be assigned to an account. And those are the properties that you get when you create a resource. All right, so I think we're sort of done with the code section portion of this. These developer hours will evolve into what they are during the 6 weeks that you'll be with us. But the goal here is to help you along your journey to becoming a decentralized app developer, not just for this hackathon, but much into the future. I'll be introducing you to tools, techniques, like we did today. We'll go into language specifics. We'll go into things, how to implement certain concepts, what to do, what not to do, that kind of thing. And for all of these, we'll start with me and Jacob, and every day at 11 p.m. Singapore time, we'll share a link in the Flow Developer Hours Slack channel. We'll also try to get an announcement out in the announcements channel. And it's great if you guys can join in the YouTube chat. We'll also try to moderate and look at the Slack channel for developer hours for any kind of questions that are coming in. And this is a great way for you guys to get your questions answered. The format, the way we envision it right now, is we'll do 30 minutes where we cover a topic. We go deep into something, whether it's Step Starter, how to set up your environment, or Flow, Cadence, whatnot. We'll actually even touch on Filecoin. And then the second part, whether it's 30 minutes or 15 minutes, whatever time that we end up having, is to try to answer your questions. So Brainchild 47, can we zoom in? Of course. Let me know if this is a sufficient zoom level for you. This is a collaborative effort. So what you guys get out of this is however much that you want. We're here. We have things to share, and we're excited to share those. But we really need your participation. So Mehrab is asking, what will be the next topic? So we did mention that we're going to cover resources a little bit more in depth during the next session. So we'll probably implement a contract, a basic contract that has a resource next session, and we'll talk about accounts and account storage. Because that's where you can hold your resources. Oh, sorry. Let me move back into the screencast mode. So this is the font size for Brainchild. We have a terminal up and VS Code, so they should be exactly the same size. So let me know if that works any better. Yeah. So we'll adjust things to make them good. This is an evolution of the process that we started with our boot camp for Flow. And just like you guys were growing in this process. So we probably will do hour-long sessions every day that the schedule allows. And I know that Friday's session will include a guest. Pon wasn't able to finish his demo of the smart contract that he wrote during the opening ceremony. So we'll have him in a half hour early. And yeah, so you'll be able to explore that concept. So oftentimes we'll do an hour. If we need to cover a little bit more, we might do half hour more. And we really expect to have you around. YouTube is the way to chat, engage with us, post your questions. We'll be monitoring Slack Flow Developer Hours for anything that comes in. We might actually do some call-ins. So if you want to be on the stream call, consider installing Skype. That's not a guarantee, but maybe we'll do that. And yeah, we really want to help everyone build some cool stuff for the Mercury Hackathon, and we're here to do that. We'll have the office hour tomorrow. Hopefully, anyone that needs any help have signed up using the calendar that's provided by Justin. What does Hackathon really expect for participants? We have a question on Slack. So the expectation is that you build something that leverages Flow and Filecoin, and it's an NFT themed project. NFTs can be really anything. Most of the time you'll probably think of Top Shot, NBA Top Shot, or CryptoKitties, CryptoPunks, that kind of thing. Feel free. We're not really forcing upon you any specific ideas. We have certain tracks that you can explore when you go to Mercury Hackathon. In fact, I can quickly open that up. So Mercury, one moment. So Mercury Hackathon 2021 is the URL. And let's see, challenge and prizes. So during the opening ceremony, we had a list of prizes. Best Filecoin and Flow browser integration project, NFT badge generator. So these are NFT focused, but there's one big track where all of y'all are competing in. And then there's also individual tracks like best NFT collateral based project. Think something like creating a collection of NFTs and then releasing tokens using the NFT as collateral so that people can have some equity in that single NFT. If it's like something that can be super valuable, or we just want to share the ownership experience. But we'll be able to discuss specific ideas that you guys come up with during office hours. So this is developer hours. This is where we'll do development stuff. We'll cover development topics. We'll cover cadence. We'll cover Dap Starter. And office hours is where you have a place to get answers on your team, your idea, your anything that's related to the hackathon. All right, so we're past the hour. Thank you to everyone that tuned in. It was a pleasure to have you, and we'll do a lot of these during the 6 weeks of this hackathon. Can't wait to see you in the next one, and we'll make sure to make the announcements happen a little earlier next time. All right. So from me, Morgan, and the rest of the team at Decentology and the Mercury Hackathon, it's over and out. Have a good day, and see you next time. Bye.